In mathematics, the adjective constant means non-varying. The noun constant may have two different meanings. It may refer to a fixed and well-defined number or other mathematical object. The term mathematical constant is sometimes used to distinguish this meaning from the other one. A constant may also refer to a constant function or its value. Such a constant is commonly represented by a variable which does not depend on the main variable of the studied problem. This is the case, for example, for a constant of integration, which is an arbitrary constant function added to a particular antiderivative to get all the antiderivatives of the given function. For example, a general quadratic function is commonly written as where a, b and c are constants, while x is the variable, a placeholder for the argument of the function being studied. A more explicit way to denote this function is which makes the function argument status of x clear, and thereby implicitly the constant status of a, b and c. In this example, a, b and c are coefficients of the polynomial. Since c occurs in a term that does not involve x, it is called the constant term of the polynomial and can be thought of as the coefficient of x0. Any polynomial term or expression of degree 0 is a constant. Constant function. A constant may be used to define a constant function that ignores its arguments and always gives the same value. A constant function of a single variable, such as, has a graph that is a horizontal straight line, parallel to the x-axis. Such a function always takes the same value because its argument does not appear in the expression defining the function. Context dependence. The context-dependent nature of the concept of constant can be seen in this example from elementary calculus. Constant means not depending on some variable, not changing as that variable changes. In the first case above, it means not depending on h. In the second, it means not depending on x. Notable mathematical constants. Some values occur frequently in mathematics and are conventionally denoted by a specific symbol. These standard symbols and the values are called mathematical constants. Examples include 0, 1, the natural number after 0. Pi, the constant representing the ratio of a circle's circumference to its diameter, approximately equal to 3.1415926535897932384626443. E, approximately equal to 2.71828818284590452353600287. I, the imaginary unit such that I2 equals -1. The length of the diagonal of a square with unit sides, approximately equal to 1.414213562373095048801688. 5, approximately equal to 1.618033988749894848204586, or algebraically, constants in calculus. In calculus, constants are treated in several different ways depending on the operation. For example, the derivative of a constant function is 0. This is because the derivative measures the rate of change of a function with respect to a variable, and since constants, by definition, do not change, their derivative is therefore 0. Conversely, when integrating a constant function, the constant is multiplied by the variable of integration. During the evaluation of a limit, the constant remains the same as it was before and after evaluation. Integration of a function of one variable often involves a constant of integration. This arises because of the integral operator's nature as the inverse of the differential operator, meaning the aim of integration is to recover the original function before differentiation. The differential of a constant function is 0, as noted above, and the differential operator is a linear operator. So functions that only differ by a constant term have the same derivative. To acknowledge this, a constant of integration is added to an indefinite integral. This ensures that all possible solutions are included. The constant of integration is generally written as c, and represents a constant with a fixed but undefined value.